Class example 2.3.1. We are going to go backwards in time here, and we're going to go back and look at what the GCF is between two numbers, and then we're going to expand that to be numbers and variables. Now, as a reminder, the GCF is the greatest common and factor. Now, we just spent a bit of time expanding. We also said that expanding is the same thing as multiplying. And we also said that there's like determining the product. Well, all of a sudden now we are going to be starting to look at what we call as factoring, which is actually the same thing as dividing something out. We don't really necessarily call it the quotient just yet, but we will in Math 20-1. So just like we know, we have inverse operations. We have addition and subtraction. Those are opposite or inverse operations. We have multiplication and division. We know those are inverse operations. When we square something, we know that the square root is its opposite or inverse operation. Well, expanding and factoring are opposite or inverse operations. So we just spent some time expanding. Now we're going to reverse that to get some algebraic practice going on. What is the greatest common factor between 72 and 48? Now, we've done this before, but as a reminder, we started this with a nice list. It was a very systematic process. We started with numbers that we're going to evenly divide into 72, and we always started with 1 and 72, or 1 in itself. Then we systematically worked up the number line. I can see that 72 is even, so I know that 72 divided by 2 is really what we're doing, right? 72 divided by 2. That actually equals to 36. So both 36 and 2 are factors of 72. I'm going to try 3. I say that 72 divided by 3, that's going to equal to 24. So I can see that I've got some more factors going on. I'm going to try 72 divided by 4. I get 4 multiplied by 18. 5 isn't going to work because it doesn't end in a 0 or a 5. So I'm going to move on to 6. I'm going to say 72 divided by 6 is 12. Now I can try 72 divided by 7, but I know that's not going to work because 7 times 10 is 70. I could try 8, 72 divided by 8. Ooh, and I get 8 and 9. And luckily we are at the end of our list, because if I went in sequential order up on the left-hand side, my next number would be 9, and it's already on my right-hand side. So now I've got all the factors of 72. We're going to do the same thing with 48. We're going to be a little bit faster with 48. Okay, so we've got all the different factors of 48. And now what we're doing is we're looking for the greatest or the largest one. So I can see 72 is not in both lists, so it's not 72. 48 is not in both lists. Ooh, but look at 24 is in both lists. So the greatest common factor between 72 and 48 is 24. Okay, between 14 and 42, this list is going to be much shorter. Could almost stop there, but I'm not going to. It's a bad habit. Okay, and so I can see 14, the number itself from that list, is the greatest common factor between the two. That's important to know as we're getting a little bit further along, that one of the actual two numbers could potentially be the greatest common factor. Okay, next one. Identify the greatest common factor of each pair of terms. So here I've got 6 to the power of 1 and 6 to the power of 3. Well, 6 to the power of 1 is just saying I've got 6. And 6 to the power of 3 is a 6 times a 6 times a 6. If I look at what's common in both of these, or the greatest common one, it's only 1 6. It's as high as I can go in this particular case. So we can say 6 to the power of 1. Or you can just write 6 happens to be the greatest common factor between those two terms. Here, 8 to the power of 4 and 8 to the power of 7. Well, if I have 4 8s over here and I've got 7, 2, 3, 4, 5, 6, 7, I don't need to multiply these out. I know that these 4 match up with these 4, and it encompasses as high as this possibly can get. So I know 8 to the power of 4 is going to be the highest or the greatest common factor in between these two. And then if I look at x's, I'm just looking for the highest power in between these two, right? You could write it out again if you really felt like it. You've got 1, 2, 3, 4, 5 x's versus 1, 2 x's. Well, the maximum number of x's that could be shared or common between these two is going to be x squared. Okay, so question C, now we're going to go a little bit faster. Identify the greatest common factor of x to the power of 5 and x to the power of 7. Well, that's going to be all 5 of those x's, so x to the power of 5. And then the last one here, identify the greatest common factor of the polynomial 12x to the power of 4 plus 8x cubed. So we're going to look at the numbers, and then we will look at the variables, and we will see what the greatest common factor is. Now 12 we know is 1 and 12, 2 and 6, 3 and 4. 8 is going to be 1 and 8, 2 and 4. So I can see 4 is going to be that greatest common factor in between those two. I can see I have 1, 2, 3, 4 x's and 1, 2, 3. So all 3 are common in between those two terms. So I've got a 4 as the greatest common factor between the numbers and an x cubed that happens to be the greatest common factor between the variables.